Hi kids, we're back at 7.6, integration using tables and other miscellaneous things. We're working on reduction formulas. Sometimes integrals involving powers can be written in terms of integrals involving smaller powers, where you keep getting them smaller and smaller until the powers can't be reduced anymore. And so we start off here, you notice we have an n is equal to 2, it's the same integral, and then on the right hand side you have this formula that you would just follow. So what we're going to do is we're going to say n is equal to 2, and we're going to say, then we start off with just saying x times ln of x to the second power, and then we have minus n, which is 2 still, so it's going to be 2 times the integral of ln of x, the quantity, and that'll be to the 2 minus 1 power, just 1. So we have that. Okay, we'll pause and take a look at that. And just as a comment here, Rule 91 in the back of your textbook is the one that we're using here. So let's copy this here, the first part, ln of x squared minus 2, and then I'm going to repeat this process, but now n is equal to 1 here. So we've got x times ln of x, and then it'll be minus the integral. Oh, sorry, I wanted to put the 1 out front. Kind of wanted to put the 1 up here too, but minus 1 times the integral, because n is 1 in the formula here. 1, and it would be times the integral of ln of x, and then it's to the 1 minus 1 power, so that's going to be to the 0 power dx. And so this is equal to x ln of x squared minus 2x ln of x. You got to watch out that you don't apply any rules with this where you might think you can bring the 2 around front, because it's not ln of x squared, it's ln of x, the quantity squared. So then what we have here is a plus 2, and really you're just taking the integral of dx, which that's just going to turn out to be, so that'll be the integral of, or 1 times the integral, 1, but there's a 2 times it, but this will just be the integral of dx. So that's just going to be x, so it's going to turn out with the 2, negative 2 distributing there, you have 2x, and then you have the arbitrary constant c. I think we have it there. Okay, and there it is, there you go, there you have it. Okay, so that's your answer for number 3 in using Rule 91. And then you have using the formula for secant to the nth power. I'm not sure if I saw this one in the back of your book, but you can see if you can locate it. I think it is there. See if you can locate that. So with this one, notice that I looked at a 4x, and I know that n is 5 for this, using the secant to the nth formula. But I also did a u substitution quickly, and then simplified matters there. So then since n is equal to 5, I'm going to carry that 1/4 out front. This is going to get long pretty quickly, so I think what I'm going to do is bring it down here. Okay, so I've got this. So it's equal to 1/4, and then I'm going to say the first part where you have this, just watching for the n power. So it'll be 1/4 times. Now it's a 1 over 5 minus n is 5. So 5 minus 1 is going to be 4. So then it's going to be secant to the 5 minus 2 power. So it's going to be secant cubed x. And then it'll just be tan x. Plus then, so we're still on the inside of this thing. And we have 3, and 5 minus 2 is 3, over 5 minus 1 is 4. And then we have the integral of secant to the 5 minus 2 power, which is going to be 3. If you recall, when we were doing integration by parts, we found the integration of secant cubed a little bit lengthy, or, well, not too bad, but if you recall, we had secant cubes on both sides of the equation. We were able to add a secant cube and get 2 secant cubed is equal to 2 terms, and then divide by secant cube. or divide by, yes, divide by. All right, so anyhow, let me get back to this one. So we've got 1/16. Yeah, just rambling about what we did in yesterday's. So 1/16 secant cubed. And so I've got the formula. You notice I put x's here. Let me go back here. We do all kinds of things like that, right? So this is u here, u, and then secant cubed u du. Okay, so we've got everything in there. Just let me check. Okay, so we've 1/16 secant cubed u tan u plus 3/16 the integral of secant cubed u du. Okay, I'm going to continue this then. 1/16 secant cubed u tan u. I'm going to pull this down a little so we can see the formula. Plus 3/16. So now I'm going to do the secant cubed integral. So n now is 3. So I end up with 1. Now I'm using the formula up here, starting there with the 1 over 3 minus 1. So it's going to be 1 over 2. 1 over 2 secant. So it's 3 minus 2. 1 over 2 secant of 3 minus 2 tan, oops, because there's x creeping in there again, tan u, and that's going to be plus, then I have a 3 minus 2, which is 1, over 3 minus 1, which is 2, and then it's the integral of secant u du. Okay, bracket here. Okay, now secant u, we know what the integral of secant u is, so we can go ahead and finish this up. So I've got a 1 over 16 secant cubed u tan u plus 3 over 32 secant u tan u, just distributing now. And then I've got a plus 3 over 32. And then times, I'm going to do one more step. Let me see. Let me stretch this out a little bit. Or not stretch, the opposite of stretch. Need a little bit more room here. So then it's going to be plus, so remember we're distributing this 3 here, so the 3/16. So we've got 3 over 32 again, and then it's times ln of the absolute value of secant u, secant u plus tan u. And then plus the arbitrary constant c. So with that in mind, then we have our integral, secant to the 5th 4x. So we have the integral of secant to the 5th of 4x dx. And we could write this in different ways. We could factor out if we wanted to, but we'll just keep it simple. So it's 1 over 16 secant cubed of 4x tan 4x plus 3 over 32 secant 4x tan 4x, and then it's plus 3 over 32 ln of the absolute value secant 4x plus tan 4x. And plus the old arbitrary constant c. Okay. And there you have it. There you go. There it is. example 4. Now, there are some other problems, and I'm not sure if we have it in there, so you may run into some sines and cosines. And the discussion that I had had been when we were doing integration by parts, is that if I have sines and cosines and powers, you'll see a couple examples in your textbook. I'd probably resort to integration by parts and just do the tabular method with that. So let me go back to one more thing in the video. There was a link. When you're doing these, it's easy. You're dealing with arithmetic and substitution. I did put a link in here for tomorrow's agenda. I'm looking for it. An integrating link. I thought I did. Not sure where I put it, but I'll make sure I put it in there somewhere for you to see it. I might have put it there. Integral calculator link. Anyway, so I'll make sure it's in there where you can check your integral in form, and so they'll throw it right into the form. Anyhow, I hope you guys have a great day tomorrow with your agenda, and I'll see you when I see you.